All right, so my name is Richard Taylor, and I'm from Charlotte, North Carolina. Actually, Huntersville, North Carolina, is right north of Charlotte. And I full stack software engineer. I organize a couple groups in Charlotte. One's the Xamarin group, which is about Xamarin mobile development, and then I also lead another group, Modern Dev Charlotte, where we talk about well, basically we're technology agnostic. So any and every tool that's out there, we present on. Blog quite a bit on at Writing Code, and I'm on Twitter quite a bit, so you can follow me there. My day job, I'm the vice president of engineering. That's just a title. I'm a software developer, hardcore. I code every day. But at Century One, we build software products for basically what's called the Microsoft Data Professional. Our software products are built to monitor, optimize, and performance tune SQL Server, and basically all of the data tools that Microsoft provides. There's our site. We're always hiring, so you can go there. You can see me afterwards, and we also have a Twitter feed as well. All right, so today enough about me, I want to talk more about basically testability of code and refactoring. So our goals today, first we want to introduce unit testing and testable code. How many are doing unit testing actively today? Okay, cool. About roughly a little bit more than half the room. A little bit. You try. Okay, all right, okay. That's where most people are. All right, so we try. So we'll introduce that, but we'll kind of move through that real quick, and then we'll talk about testable code a little bit more. And then we'll explain how to refactor code to increase testability, which is very important and a big challenge in a lot of shops. And then I have this is sort of code heavy, so I only have a few slides, and then we're going to actually get into some code, and we'll look at some examples, and we'll actually refactor some code, and we'll take a look at it, okay? So we'll definitely walk through those things. All right, so let's just jump right into it. So what's unit testing? Obviously, unit testing is a process where we're going to test a unit of work in our code and make sure that it functions properly. It can be done manually, but most often it's part of some framework or build process, so it's automated, right? And it's not test-driven development, so a lot of people get that confused. Unit testing is a component of test-driven development, but it's quite different. It's something different. So, and then unit testing should be isolated, which is a key point. Testing more complicated scenarios is something that kind of falls in the realm of integration testing. And so when you think about things like you need to access a database or make an API call, things like that, that's more complicated. That's not technically a unit test, and it's integration testing. And we'll see some examples in our refactoring on how we actually move through that and get through that. So there are a few styles in unit testing. The first style is output verification, and Actually, I have a couple slides on that, so we'll get into that. Then there's state verification, and then there's collaboration verification. So what are those styles? What do they mean? Well, output verification simply means that your set or system under test is going to have a set of inputs, and we have an expected output. All right. And when we think about the value of unit testing, this is probably the most valuable, at least in my opinion. It's going to tell you exactly what's wrong, where it's wrong. There's not a lot of gray areas, not a lot of research you need to go into. It's basically going to identify the problem, right? State verification is a little bit more complicated. Basically, for a given set of inputs, you're going to actually test the state of the system. So you might actually take a look at multiple different properties, things like that. But it's a little bit more complicated. In the sense that there's a little bit more work involved in determining what exactly went wrong, but it's still of high value. So think of a situation where you had let's say a class with various properties, you call a method on the class, and then you actually have to at least test those properties, make sure they have the expected value. So there's multiple asserts that you're doing in that scenario, but still very high value on I guess the value scale. And then collaboration verification. So basically what this means is that your system under test basically is working with other systems. And what you're looking for is did they interact in an expected way, right? So did a method get called, or did you get a return value that's expected? Now, the problem with this, and it does have value, but when you look at the entire scale, it's probably the least valuable. It can be brittle, right? Because those other dependent systems, you have no control over. They can break, and of course you can get a failure on your test. So you have to do a little bit more investigation, right? So it's not going to point to exactly where the issue might be, but you do get some value out of it and some exposure to what might be going on. So, so why do we do all of this? Well, I believe the number one reason we do this is to increase our confidence in code changes, right? So your new devs on your team, they have an assignment, not familiar with the code base, they need to make changes. It kind of gives them those guardrails, right? And if you're like me, I don't remember what I coded 6 months ago. So if I'm going back to it, it's like, what the heck was I thinking? Yeah, the test will actually keep me sane, right? So that's number one. To find errors early, right? So typically your tests are part of some build process, right? So if you're making code changes and you do a local build, and then obviously if there's something that breaks, you don't want that to get further down in your pipeline if you have a lot of automation and integration going on. So find errors early. And then to provide some documentation. So this is an output. You can be a little bit more intentional with your tests in terms of like naming and things like that. But for the most part, your tests, if you're reading the code, it's really going to tell you what's going on there and what's the intended functionality. And then to help facilitate better software design via refactoring. So we're going to actually take a look at how taking, let's say just to call it non-testable code, and actually refactoring it to be testable, and how that's actually going to enhance your software design. Okay? All right, so what is testable code? Well, the first thing is that it's deterministic, right? You can actually, in a reasonable fashion, understand that, hey, when I run this code with a given set of inputs, I'm going to get a certain set of outputs. So it's deterministic. So that's number one. Number two, it's loosely coupled, right? So it doesn't have a lot of dependencies. A good example, let's say you needed to test a class, but it was, let's say it was static, right? And this is part of your application. Well, the only way it exists is unless your application exists, right? So in a simple form, that might be okay, but if it's a very complicated application that takes a lot of startup, very, very hard to test, okay, if it's tightly coupled, right? All right, so code that does not hide dependencies. And so you're exposing things that, let's say, for example, you have a class that's exposing methods that really is not part of the interface, right? The public interface, it really shouldn't be public, right? So you want to make sure that they're inside of the API itself, or at least the public interface, that what you're testing doesn't have any further dependencies, I guess, in a dependency chain. So a good example might be a method that actually news up other objects, right? You have no control over those other objects in the sense of a unit test, right? So you don't want that to occur, and we'll see that example. And then code that basically follows the single responsibility principle. Again, if you have a method that you're testing and it accesses a database, and then it actually performs some calculation, and then it news up an object, and you return that object as the return type, that's a lot of responsibility in one method. And I've seen a lot of code that's like that. That's very hard to test, right? So we definitely want to follow single responsibility. And then code that effectively hides the implementation details, right? So a good example might be back to the public interface. You have a method and it calls a couple other methods. You want to make sure that in terms of your testability, that those implementation details are basically not part of that the public API. So we'll take a look at that as well. So how do we refactor code to be testable? We remove any non-deterministic code. All right, obviously. Tight coupling, remove any hidden dependencies. Update code to follow the single responsibility principle. And then we isolate domain model. So this is a little bit, we'll actually get into this. I'm a fan of clean architecture, onion architecture. We'll take a look at that and why that's so important. And lastly, testable, or at least refactoring code to be testable, we want to hide implementation details. All right, so enough of the slides. Let's get to the code. So, in our first example, can you guys read the code in the back? And I need to zoom in more. You guys are good? Okay, cool. All right, so I'm going to set up a scenario, and it's part of our problem domain. Okay, we have basically we have a price calculator. Okay, so just think retail, and basically the rules are if somebody buys something before 9 a.m. And it's sort of like an early bird special type of thing, you get a 20% discount. If you buy something actually before 10 a.m., if you buy something between 10 and 12 noon, you get a 10% discount. And then anything after that, you pay the retail price. Okay, so that's our business rules, right? Okay, so let's take a look at the code. So we have a class within our program, and basically here's the rules coded out. All right, so first thing we take a look at, you see the rules. If we get the system time, we look at the current hour, and if it's less than 10, we give you a 20% discount, 10% discount between 10 and 12, and then retail price, right? And then when our calculator returns the final price, okay? All right, so, and here's our method, our main. We're gonna run it, we get a new price calculator, and then we're going to get the output. So I'm just gonna run this real quick. And we will see here. Okay, what time is it? It's before noon, or it's before noon, but it's after 10, so we get a 10% discount. So you see the base price is $10. With our discount, our final price is 9. Okay, so real simple, it works. All right, so now we want to test this. All right, so, and we just want to test our simple business rules. All right, so we have 3 tests we created, and I'm a little wordy with my test names, but for a reason. Okay, remember that documentation point I made? So if you take a look at this code, you'll see the first part of, here's my first test right here. And I've got calculate final price before 10 a.m. All right, so that is basically my system under test. I'm defining what I'm testing. Second part of the name says base price $10. So that's basically, my inputs. And then my expected result is the last section, final price $8. Okay, so very descriptive. I understand what's going on there. The next person understands what's going on there. If I look at this 6 months from now, I understand what's going on. And also, it kind of, if you're looking at some kind of like in Visual Studio, how I organize the test or some other tool, you kind of get things kind of grouped together. So it works out quite nicely. All right, so let's dig into the test. I knew up my price calculator, and then I run calculate final price with 10 as an input, and my assertion, I expect $8, right? Okay, so that's before 10 a.m. This is between 10 a.m. and noon, so I expect $1 off if it's $10, right? 10%, and then I expect my retail price if it's after 3 p.m. in this scenario, right? Okay, so I'm going to actually run my test, and I'm going to get a failure, right? Now, you guys saw the program actually work, right? But there's a couple problems with what we got going on here. Our method, calculate final price, if we take a look at some of the, or we consider some of the principles around testable code, it's not deterministic. And the reason it's not deterministic is because I'm actually basing my calculation off of system time, right? I have no control over system time, right? But think about it for a second. The program actually works. It is functionally correct, right? So, but my tests are saying, hey, wait a second, something's wrong, right? And that's what's wrong. All right, so let's take a look at it being refactored and actually improving our testability. All right, so I'm going to open up the refactored solution. Actually, it's simpler if I do it this way. All right, so what I've done is now I've changed the signature of my calculate final price. So now the dependency on system time is actually provided as part of the constructor, right? So you see current time. The rest of the logic is the same, right? So you can see I have my same set of tests, right? And expected results. I didn't change any of that. So I'm going to build this. Now, because time is not, or time is now something that's part of, I guess, my control, right? Now my tests work. So now I have a much more, I guess, easier way, not much more, but an easier way to actually control how I'm going to actually do the test by providing that value, okay? So it's pretty simple, but again, that's an example of where we had working code, but we weren't able to actually effectively test it, right? Okay, all right, so now let's dig in a little deeper. So let's take a look at tight coupling. And so what we've done now is we've expanded our problem, or at least our problem domain, all right? So now we still have our price calculator, but now we have this concept of a cash register. And a cash register, what it does is it actually takes data that has been persisted somewhere, like let's say somebody's checking out, and for each line item, for each item, we've got a price, right? It's going to actually take that list, it's going to run through that list, and then actually going to produce the pricing, okay? All right, so I'm going to run it, and we'll take a look at the results. And you will see now we have a collection of results here, right? So for each one of those prices, I'm actually calculating, and as you can see, for each one, there is a discount, and it's applying our same rule. So there's a 10% discount, okay? All right, so we have a little bit more complex system. If we take a look at the cash register, you'll see a couple things here. We have this concept of a price data repository that we're actually creating as part of the constructor for the cash register. And then that repo is going to calculate the final prices for each one of the items in the database, right? And then we're going to cycle through, create a pricing record, and that's what we're going to add to the results. Okay, very simple. The repo, I mean, in this case, it's just and actually I'll show it to you. It's just it's just a class here, and what it does is it generates 10 random numbers, 10 random prices, and it spits them out, right? So imagine that being a file that we're reading from, a database we're querying, or an API call. It can be any of those types of things, right? It's just some external system we're reaching out to for data, okay? So it works perfectly fine, but we're on this mission of code coverage and making sure that we have some adequate tests. So how do we test the cash register? Well, it's pretty difficult, right? Because we have the cash register is actually creating this repository that has some data that we have no control over, right? So it's very difficult and almost impossible to actually create that unless we had control over maybe the data store, and we actually can seed it with some data, which I'm pretty sure most of you have done, this known data, and then actually run it on that, which is possible. But there's a better way. All right, so let's take a closer look at how we might accomplish that. So let me close this and actually open up the Refactored Solution, and we'll dig into it. Okay, all right, so I'm going to introduce a couple concepts here. So let's take a look at our cash register first of all. So a cash register now, if we look at the constructor, the dependencies it needs are actually provided, right? So we're actually providing the repository, we're actually providing the current time, right? And the current time is the deterministic issue that we had before, right? So we're solving that part. And then the price repository, remember we had a dependency there, no control over the data. So instead of writing our cash register or allowing our cash register to actually code against or use the concrete implementation of a pricing repository, what we're going to do is we're going to actually code it against an abstraction, right? And so everything else beyond the signature change is pretty much the same. Okay. All right. So that's cool. Now, this I repository or price data repository, if we take a look at it, it's just an interface. It has two things, right? It has pricing data, which is basically our list, and then it has a method for calculate final prices. And in this example, now our price data repository actually implements that interface. And nothing's changed here other than in implementing the interface. We have our 10 random numbers, we run through our calculation, and we provide a list. Okay, so why is this important? Well, to prove that our program still works as it did before, here's a quick run, and you'll see, since it's not noon, there's our 10% discount being calculated in, so we're all good. But now, we're able to write tests against it. So if we take a look at our tests now, we've grown from 3 tests to actually 6 tests, right? So there's our original 3, and here's our additional 3 that we added for the cash register. So let's take a look at that. So here's our test. Now, again, I'm a little wordy with my naming. But you can see, let's take a look at the first test. You'll see we're doing calculate final prices before 10 a.m., base prices from 1 to 10. That's our input. And then our expected output is each final price has a 20% discount. Okay, so there's this new thing we introduced in our test is a mock of the price data repository. We'll take a quick look at that in a second. But you see here now what our cash register is taking is the my price repro, which is what I created, and then a date and time, which is the new signature on the cash register. And then what we're going to do is we're just going to loop through those. And we're going to, for each one of those, and it's a controlled environment, right? It's deterministic. We have prices from 1 to 10. We're going to actually calculate the final price. And since we're sending in the time and we're controlling the repo, we should be able to assert that for each one of those values, we should have a repeatable and deterministic result. Okay, so let's take a look at the mock price data repository. Again, it's implementing the interface that we are actually implementing in the program, right? So now I can send this in just like it was in the external repo. And it's implementing, it has a price data list, it has the method itself, and you see I'm just looping, and actually 1 through 9, I'm looping through the pricing, my control pricing, adding it to the data, so that's available for the test, okay? All right, and I rinse and repeat for between 10 and noon, so you'll see there's 11 o'clock there I'm sending in, and then I can also test the same results for something afternoon, that's 12:30. So if I run this, you'll see that all of my tests should pass. Actually, I need to build. All right, so we get green lights. So now everything's deterministic, it's control. We've actually, now we're providing the dependencies via the constructor. And basically I can continue to test if I wanted to add more tests to this scenario. So before, didn't have control over the repo, now I do via the abstraction using interface. Now we can take this a little further. I wanted to keep this example simple so that we can get the concepts, but in most real world applications, we get into situations where we use a dependency injection container, we define a mapping between interface and the concrete implementation. So at runtime, you're able to provide what's necessary or at least the dependencies that are necessary for a given method or a given class. And And then for mocking, usually there's a mocking framework that we use to actually mock out our mock so that we can actually provide it during a testing scenario. So any questions on any of that? Pretty straightforward? Yes? Yes?
Is there any particular mocking framework you prefer using?
I use mock. Yeah, that's the one I use for, I'm a .NET programmer, that's the one I use. It's, yeah, MOQ, yep. Obviously there are many others that you can use. All right, so now we've improved the testability of this particular scenario. So now let's take a look at another scenario. All right, so isolating domain models. All right, so we're starting out where we left off. So basically everything is, everything is exactly the same. All right, so we know all of this works, no need to run through it. But I want to show you something that's a problem. Actually, there's quite a few problems, but here's an example where when you don't isolate your domain models, then you run into a lot of other dependencies. So take a look at this line 11 where I'm newing up my price calculator. Well, the class itself, the calculator class itself, is actually part of the program, right? The class is internal to the class, or it's wrapped by the actual program that represents, or at least the class that represents the program. And the same thing for the cache register. You see line 18, see program.cache register. Now that's cool with this simple example, right? But again, if it's a very complicated application that you've got running, you don't want to stand up your entire application, or even if it was even if it wasn't the application, but let's just say it was just much more. You had classes within classes and things like that, and that was sort of your design. That still can get pretty complicated, right? And it creates a lot of dependencies. You don't want to do that. So there's a much better way to actually handle that scenario. So what we want to do is take a look at how we can improve that. And this is where, like, I'm a huge fan of clean architecture, or at least that design principle, and what it can do for you. Okay, so let me close out all of these before we get into the. Let's take a look at the project itself. So there's been a lot of changes in in what's done here. So for example, we started out with basically two projects, right? We had the program itself, and then we had the test project, right? So now what I've done in this code is basically we've taken, let's start with the domain models, right? So we had a couple of domain models. We had a price calculator, and then we had a cache register, right? So we isolated them, and we actually put them in their own project. So you'll see isolated domain models.core, and then there's a folder in there called models, and then there's our cache register and our price calculator. Now, in order to effectively implement clean architecture, your domain models and really the project that they're part of should not take on any dependencies, okay? And I can prove that by what we have set up here. If we look at the dependency node on the tree, you'll see there's no dependencies to any other projects for those domain classes, okay? And we'll see why that's important in a minute. All right, the other thing that we've done in this project is, or at least this solution, we've actually created a isolate domain models.data project, and that's where we moved all of our repository operations and representation and things like that. So you'll see a folder there for interfaces, and there's our iPrice data repository, and then we have a folder for models, our price data repository, the implementation. All right, and then in our program itself, well, actually, before I move on to that, if we take a look at the dependencies on the data project, there actually aren't any here as well. All right. Now, sometimes, you know, depending on your solution, this project itself might reference the core project where all of your domains objects are. So think of, it's also commonly called an onion. So your domain objects are in the center, and then anything that's dependent upon those are actually outside. So if your data project required, it would reference into your core project and so forth and so on. In this case, it wasn't needed, but that can happen. And then of course where our actual running application exists is right here, and it's dependent on a couple projects. It's dependent on the core and the data. All right, so why is that so important? Well, if we take a look at our pricing calculator test. So the price calculator itself, before was part of the program. So we had to actually instantiate the program to actually get access to that class and actually instantiate that so we can actually run our test. Now, because the domain model is isolated, I can just new up a price calculator in my test and run it. So I have no dependencies on anything that the program would have had, right? Same thing for our cash register. We now remove that dependency and it's isolated so that now I can just new up a cash register, give it what it needs, and go from there. Now, there's one change, and actually, if we take a look at the price data repository. Okay, before the way it worked was that we actually had to. Actually, I'm sorry, not the price data repository, the actual cash register. The way it worked before, we had to send in. Whoops, I was thinking I'm trying to move it. Before, we actually had to send in a repo as part of the constructor, and then we access the price data on that repo and cycle through that and provide the results. So now we've changed the signature of that, and we're just providing a simple list. Okay, so now we've broken apart that dependency between those two objects, and now it just wants a list. And now what change that requires is that in our tests and actually in our program, when we want to test the actual cash register itself, we're going to create an instance of the mock data repository, run calculate final prices, and then we're going to send in the list. Okay, if that didn't happen, then it would be very difficult to actually maintain the whole concept of isolated domain models and things like that, because there was no real way. Actually, the only real way in our previous example was to actually in the core project reference the data project so we can actually get a reference to the repo. We didn't want to do that, right? Even though it would work, right? So this is obviously a better solution. And so if we go all the way up to our program itself, you'll see now we create a repo, and then we basically do the same thing the test did. We create a cache register, we pass it the data, and then we pass it in the runtime date time, and then we go ahead and run through our process. And I'll run it real quick. And we should get our expected output. So our expected output of our 10% discounts. And if we loop all the way back up to our test, we run all our tests, and everything's green. So any questions on isolating your domain models and how that worked? Pretty straightforward. Anybody using the clean architecture on their day-to-day job or their solutions? Okay, cool. Yeah, a couple people. Okay. Yeah. It in and of itself, I mean, it really contributes to not only the architecture of a system, improving that, but also the testability of your code, being able to basically instantiate your business objects and test them in an isolated fashion from the rest of the system. It really works really well. All right, so All right, so I did create a repo out in GitHub with all of those examples. You can definitely go take a look at that. Those are 3 of maybe 5 or 6 basically techniques for refactoring your code to be testable. But those are definitely concrete examples, and there's both examples there. So or both scenarios. So before refactoring and after refactoring, so you can kind of look back and forth. There's a link here to a good article on unit testing and why it's important. So you definitely want to take a look at that. I'm a fan of Pluralsight. So here's a couple of Pluralsight courses: building a pragmatic unit test suite, writing highly maintainable unit tests, and advanced unit testing. In that order is basically the complexity of the presentation. So if you go through that, you want to take a look at that. I did another talk on raising the value of a unit test, and in that talk, there's a YouTube video of it. It's more about naming conventions and value and how to improve them and that sort of thing once you have a suite of tests. So if you're interested, take a look at that. In this particular example and presentation, we use MS Test. So here's some links to various testing frameworks, obviously the popular ones. MS Test is obviously part of Microsoft suite of tools, but in-unit and X-unit, for various reasons, they have some advantages to MS Test that you might want to take a look at. So as far as code and basically content, that's my presentation. Are there any questions about what's going on? Yes?
Can you talk for a minute about taking a piece of non-deterministic, tightly coupled code and ensuring that in your refactoring to loosely coupled deterministic code, you have it supposed with something?
No. So good example. All right, so let's take for example the method that I kind of alluded to before. First step was to grab some data from some external source, then run some business logic on it, right? And then create a new object and then return that as a return type. So those 3 steps. So first of all, single responsibility, that's a problem, right? It's non-deterministic because you got an external call to a repo or service or whatever that is. And then it's also tightly coupled because you're actually newing up a new object and you're returning it. So you're dependent upon that object as well, all right? So how I go about dealing with that, as an example. All right, so the first thing I would do, I'm going to hit a couple of different, I guess, issues because it's kind of hard to isolate each one. So let's talk about the business logic first, right? So what I would do is I would actually write a set of tests to test my business logic, right? So I'm going to go test-driven development. I'm going to write a set of tests. And basically, obviously, watch them fail, right? Because there's nothing to run against, right? So that'd be my first step. Okay, and then my business logic, obviously, in those tests, I need to obviously make sure that I'm pretty confident that the functionality that I'm expecting from my business logic is tested. Okay. The next thing I would do is I would actually create a class, and that will represent my business object and the business rules related to it, whatever they may be. Okay. My test would actually instantiate that class, and I would watch that fail. Okay. And then I would actually take the code out of that method, and I would actually make it a part of that class and work with it until it passes. Okay. So then going back to the original method, I would actually now I can do 2 things. One, I can actually instantiate that new class, but then I'm right back to a tightly coupled scenario, right? So that could be a first step, but then the final step in that part of the fix would be to actually provide an abstraction. So I'd build an interface for that class that I just created, and then I would actually make that injected as part of the constructor for the original method, all right? So, and then I would operate. So now I've taken my business logic and I've moved it into a state where it's testable, and I have tests that are associated with it. So let's just call that step 1. That was a lot, but that was step 1. All right. All right. So then, and then from there, what I would do now is And I will add to that, let's just say this was a production system, so I definitely want a DI container, so I would actually set all that stuff up, do the mapping for the interface that I created to the concrete implementation, and inject that at runtime as part of that original method. All right, so that'd be step one. Step two, I'm going to deal with the data now, since there's a data access step, right? So basically, I'm going to use a repository pattern. I'm going to actually create an interface. For the repository, I would actually create the class, let it, whatever methods I need on that, I would do that for the data access. And then I would write tests for that as well, right? So now I've got and sort of the same process. I would now make that part of the constructor, do the mapping in my DI container for runtime, and then obviously I have my test now, so I run through all of that. So now I have a way to control the test. Control the test around the repository. Okay, so now I've removed the repository, I removed the business logic, so now I'm then the newing up of the object. One might argue if I'm just returning that class or that type, that I just new it up, set the values, and I return it. There's not a lot of business logic there, but that's a huge assumption, right? That there could be business logic in the constructor of that class, right? So I want to do a similar thing. I want to actually abstract it away, create an interface, set up my tests, map it in a DI container, and now test my class independently of that method. It's working fine now, and then now I want to actually update my constructor, so now it has 3 interfaces that it's accepting in the original method. And then now everything is deterministic. It is single responsibility, and basically it's testable at that point. So it can be involved. In that particular scenario, it's rather simple, but it was 3 steps. But in the course of maybe an hour and a half, you could probably, if you're familiar with how to do this stuff, you can probably get that done fairly quickly. So that would be my approach in that particular scenario. Now it can get much more complicated. So like the system that I work with at work on a day-to-day basis, it's about 14 years of development without testability in mind. So there's a lot of statics and things like that we have to deal with. This is a huge application, right? And so you go down a rabbit hole at times, right? So you'll see situations where you're down deep in the code, you got this method and it relies on this static, that relies on this static, that relies on this static, that goes all the way up the dependency chain, or at least the object graph, to the actual application itself, and trying to unwind all of that, going from the statics to abstract interfaces and things like that, and use a dependency injection. It could be a chore. But the end result is that if you think about it from a long term, like we have a team of 40 people, to go through a release, it could take us a sprint, which is 15 days for us to actually run through all of our tests and make sure that it's all good. Now, that could be after several sprints. Well, if we can unwind a lot of this stuff, have a lot of automation as devs are actually changing things and updating things and extending things, we're knowing about issues because we've got a lot of automation at that point. So, it might take you a while initially to get everything unwind, but in the long run, across a team, that can be a huge savings. So that would be one scenario, one way to kind of walk through and set this stuff up. But it's actually, I kind of find it fun. I mean, it's kind of challenging in a sense, particularly when you like what we deal with and all of these huge object graphs and dependency chains, and it can get kind of crazy. But that's how, in that scenario, that's how I would unwind that. So you're welcome. Yes, sir.
You mentioned kind of TDD and Refactor.
Yeah.
Does everybody on your staff kind of follow that, or is it a work in progress? Or?
So we're in a unique situation. So we have our existing platform. It's what we sell every day. It's what we work on sprint by sprint. But we're working on the next generation of our suite of products, and this is an opportunity for us to actually unwind all of that and make it testable. So the edict at this point is everything you write is testable. It will have unit test, and basically some of these techniques that we talked about is what we go through. But it doesn't mean that we don't actually implement some of these techniques on our existing platform. So we have an architecture group that's actually separate from the engineer. Well, it's part of the engineering, but it's separate from my group that actually codes. And they work on some of these things. So a good example is we just brought in a branch from our architecture group that refactored a lot of code to implement the repository pattern on just about all of our data access. Now they didn't give us all the tests that went with it, but they actually gave us the infrastructure. So now moving forward, any data access that we expected to use the repository pattern and so forth and so on. So I'm not going to say if you have an existing platform, I'm not going to say it's easy, right? There's a cost, right? And it's tech debt. I mean, to be honest with you, and so you have to kind of work through that. But our developers are pretty good about testing, and they try to test when they can. Now, the other thing I did want to mention too is that the way we look at automation and testing on our team is that we try to do unit tests, right? And this is sort of the process everybody follows. We try to do unit tests if we can. If not, then we move up to integration testing, which is still part of our build and automation suite. As a last resort, well, actually not quite last, but from an automation standpoint, a last resort is code to UI. Now, code to UI I didn't talk about, but basically that's UI-based automated testing, right? Hugely unreliable, extremely slow, and quite frankly, you never want to get into a situation where your devs are not, they basically don't have a lot of confidence in the testing, right? It just brings no value to the table. Yeah. All right. So, and then lastly, manual testing. So each dev on each issue, each feature bug, that's sort of the process we go through, right? And so there's a few other options in there. I mean, we'll look very heavily at whether or not we should do code at UI. As a matter of fact, it becomes a heated debate. I had a meeting with my team leads yesterday, and we got into this heated debate about code at UI because some were arguing that we have no other option. I'm arguing, well, that's sort of legacy. We're moving into this new world. Let's just not, we need to consider how much we want to invest in that type of testing. And so code UI for us has been not, the return on investment for us has not been what we expected. So we try to push integration and unit testing. So any other questions? Yes, sir.
Yeah, you tend to pass your dependencies as parameters, right? But some people tend to use the dependency injection, and then you have implicit parameters. So I gather you rather not use dependency injection.
No, that constructor, so for passing your dependencies as part of constructor parameters, that is a form of dependency injection. So I can actually, so in my examples, I didn't kind of muck it up with and complicate it with a DI container and any kind of stuff because I wanted to make sure we got the concepts. But I can take that very same code, and then at the start of the program, I can actually create or use a dependency injection library, and I can actually basically map the interface to the concrete implementation, and it will work as is, right? In my test, I'm actually newing up a mock and sending it in as part of the test, right? And actually in my program itself, like if you look at the main method, I actually am newing up a repository, but I don't have to do that. I can actually use a DI container to actually make that happen, okay? Any other questions about testing or any of that sort of stuff? Yes, sir.
I'm curious, is like, say you're gonna bite the bullet and you're gonna actually try and unwind that module.
Yeah.
You obviously don't have tests yet. Is there anything that you do to try and not blow yourself up in the process, like to make sure that your program still does, because that's what you don't have?
No, absolutely. So that, yeah, it's sort of like chicken and egg, kind of. Yeah, no, yeah. So you're absolutely right. So what we try to do is we have a suite of test cases that have been basically created in the past, and it's part of our manual, testing or whatever. And so unfortunately, well, I don't think a lot of shops don't have a lot of documentation, to be honest with you. So we're in the same boat. So what we have to do, there's a number of things we have to do. One is we have to validate our test cases in that particular scenario, make sure it's correct and it's expected. Shore it up if there's anything missing, right? And then the developer at that point will basically start writing the test around it and watching them fail. And we usually bring in, so our QA folks we actually call them SDET, so they're actually developers. We bring them in as well to validate that the code that they've written.
Like TDD and like re-engineer it?
Yeah, pretty much. I mean, yeah, pretty much. I mean, we
Just send it to like UAT or whatever and make sure it's still.
yeah, we'll run it through a couple of manual runs as well before we sign off and say, yep, this is good. But that's really the only thing we have, and it's the only way we can actually get it done. It's tech debt. It's major tech debt, to be honest. Yeah,
I cross my fingers and hope I'm not good. Like,
yeah, it's major tech debt, and the only way that I found that you can really dig into and get it done is just bite the bullet and actually write the test, and you might uncover something. I mean, we've uncovered some things as well, some edge cases that when we actually sat back and thought about how to test it.
yeah, you didn't understand what you were trying to do in the first place.
Yeah, and then we found some edge cases and actually were able to close those along the way. But I'm not sure how you actually.
That's cool. I
Yeah,
thought
actually.
you had a strategy. Given the call.
I wish I had a better one, but it's just tech debt you got to pay, unfortunately. So, any other questions? Awesome. Well, I appreciate your time and joining me this afternoon, and good luck with your testing.